Hello again, algebra students. We're going to spend one more day working with solving systems of equations with elimination. In case I haven't mentioned it yet, elimination is my favorite way to solve systems of equations for most of the problems that we're going to encounter. In this first problem, I want you to remember the whole idea behind elimination is we want to get one of the variables to go away. We want them to be opposite coefficients. And we already have that in this problem. For my y's, one of them is a positive 2y, the other one's a negative 2y. When I add these two equations together, those y's are going to be eliminated. Now, also I want to mention this fancy little squiggly set bracket right here. That's just the way that some books or some different ways of writing systems of equations, that's just showing that those two equations go together. Don't worry about that. You don't have to write that down. I just wanted to point it out that it's not really a big deal in terms of the math. So we said that the positive 2y and the negative 2y are going to cancel. This is a 1x, this is a 1x, that gives me 2x. And when I add the 8 plus 4, I get 12. So dividing here, I get that x is 6. And remember, you can't stop there. That's not your final answer. I still have to figure out what the y is. Now, unlike substitution, where I would say, hey, let's just go where it says y equals. I don't have a y equals right now. So I'm going to go to either one of the equations. It doesn't matter which one. I prefer the top equation just because the coefficient, the number that's with the y, is positive. So I would use this equation right here. Instead of the x, I would write 6 plus 2y equals 8. And then we're going to solve this. We'll get rid of the 6. 2y equals 2. And then divide by 2. And again, some people are like, yay, I'm done. Not quite. You need an ordered pair. X and then y. And remember, you can always substitute those numbers back in to make sure that it works. Since we just used the top equation, let's use the second equation. This would be 6 minus 2 times 1 is just 2. And 6 minus 2, yep, that is equal to 4. It works. In this problem, my y's are opposites. Yay, we're happy. The problem is, not everything else is lined up. The equal sign is sure, but one of them has an x on the left side, one of them has an x on the right side, and the constants, the regular numbers, are also not lined up. So I have to rearrange one of these equations. It doesn't matter which one. It doesn't matter which one they look like. In fact, in this problem, I would maybe even, instead of trying to get my x's all on the same side as my y's and my numbers on the other side, which you certainly could do, we could also just take both of these and get the 8y and the negative 8y to be alone on one side of the equal sign. It's just an option for how we can solve this. So I could subtract 3x. So this top equation would turn into 8y equals, now remember, the negative 2 and the negative 3x don't match. So we're going to have negative 3x minus 2. And in the second equation, let's move the 14. I know that this means that we're changing both equations instead of just changing one of the equations, but it's an option that you have because it's still going to get everything lined up the way we wanted it to. The y's are lined up. Oh, I missed my negative. My equal signs are lined up. My x's are lined up. And my numbers, my constants are lined up. When I add the 8y and the negative 8y, that's 0. There's my equal sign. Negative 3x plus 5x is going to be 2x. And negative 2 plus 14 is going to be 12. Now, don't get intimidated by that 0. And also, don't just try to divide by 2 right now. We have to move the 12. Negative 12 equals 2x. And then divide. X is negative 6. Now, I want to find the y. In the last problem, I just said, this isn't like substitution where we have y equals. And we still don't, but we almost do. If I look at this equation right here, I realize that it's rearranged a little bit, but the 8y, yes, there's a constant in front, a coefficient, but the y is almost by itself. So I'm going to use that equation. 8y equals negative 3, and then instead of the x, I'll put in my negative 6 minus 2. Negative 3 times negative 6 is 18. Minus 2 would give me 16. And divide. It's the y is 2. So I have my ordered pair now because the x was negative 6 and the y was 2. In this problem, I can see that it would be tempting for some people that really like substitution to do this one with substitution. I don't have any variable entirely by itself, but it wouldn't be hard to get that. However, I would prefer to take, for instance, my x's that match exactly. They're both positive 1x right now. If I could make one of them into a negative 1x, I'd be set. I would have opposites. So I am going to multiply this top equation by negative 1. Now, some people would want to rewrite both equations. For me personally, I like to take this and I'll distribute. And instead of writing it over on the side, I'm just going to write it right here. So it's still lined up and underneath now instead of above my other equation. So negative 1 times x is going to be a negative 1x. Remember, this was a positive 1x. Negative 1 times y is a negative 1y. And negative 1 times 1 is a negative 1. Now when I add these, my x's will go away. 3y plus a negative 1y is 2y. And 9 plus a negative 1 is 8. So y is going to be 4. I would choose the top equation to find the x. I would have x plus 4 equals 1. So we'll just subtract 4 and get that x is negative 3. So my ordered pair, x and then y, negative 3 and 4. This time everything is lined up. However, I don't have any variables that have matching coefficients. I also don't have any that have opposites, like a positive and a negative, I should say. So I have to decide if I'm going to make my x's be opposites. In that case, I would keep the top one to be a positive 3x, and I would want to make the bottom one into a negative 3x. Or the other option is I could be looking at my y's. Since the bottom one is a positive 6x, I could make the top one into a negative 6x, or I'm sorry, y's. They're not x's. I'm going to choose in this one to try to keep my numbers smaller. I'm trying to get my opposites as my x's. So I want to keep that top equation exactly as it is. I want this to turn into a negative 3x. And then remember, I have to distribute to everything. This time I can't just like move that one, kind of make it line up nicely. I'm just going to rewrite this one. So I'll have 3x plus y equals 13. And when I distribute negative 3x, negative 3 times 6y is going to be a negative 18y. That was really a 1y right there. And negative 3 times a negative 7 is a positive 21. So my x's, my wish was granted. They're going to go away. Positive 1y and negative 18y will give me a negative 17y. And when I add 13 plus 21, I'm going to get 34, which divides nicely by negative 17. Once I know what the y is, I'm going to go back into one of my equations. It can be an original equation or the changed equation. I kind of like this equation that I actually changed. I'm going to use that equation because, remember, I'm looking for the x. Here I don't have a number in front of the x, so I won't have to do any division. So I'll have x plus 6, and then instead of the y, I'll have a negative 2. So I have x plus negative 12 equals negative 7. And we'll just add the 12. So x is 5. And as you can see, it does not matter if you find the x first or the y first, but you do need to put them in the ordered pair correctly. This time, my x's, I can't just change one of them nicely. I can't multiply by a whole number and get it to be the opposite of what I have there. I'm going to have to change both of the x's. 5 and 2, the smallest number I could get them to be would be 10s. So I'd have to get a 10x and a negative 10x. However, if I look at my y's, this top equation has a negative 2y right here. If I could make this into a positive 2y, I just have to think about what I did, multiply by. So right now it's a 1, I'd have to multiply it by 2 to make it into a 2, but that's a negative 2. So I'd have to multiply by a negative 2 in that equation and distribute that through the entire equation, right? So the first equation we're just going to keep. 5x minus 2y equals 3. Second equation, that'll be a negative 4x. Negative 2 times a negative 1y is a positive 2y. That was what we wanted. And anything times 0 is still just going to be 0. So the y's will go away. 5x plus a negative 4x is just 1x, or just x. 3 plus 0 is 3. Once I know what the x is, I can go back in and find the y. Doesn't matter which equation we use, or again, we can use the adjusted equation that we used, that we created. I think I'm probably just going to stick with the second equation, just exactly the way it was. So I have 2 times my x plus a negative 1y equals 0. So 6 plus negative 1y is 0. So we subtract. Oh, and I just lost my connection there, but I'm going to divide by negative 1. See if it'll come back quickly, I hope. When we divide by negative 1, we're going to get that y is positive 6. Come on, smart board. Be smart for me. There we go. So if I divide by negative 1, the y is going to be 6. So my ordered pair would be 3, 6. I know I haven't done a good job of checking these, but I promise every one of them you could check. Okay, here I can look at my x's. I could make my top equation have a negative 4x and then the positive 4x in the denominator, in the second equation, not denominator. Those would cancel. Or I could look at my y's and say, I do like that one of them is positive and one of them is negative. However, I have to change them both, make them into 14s. And I'd rather not have to change them both if I don't need to. So I am going to work on my x's. I want this top equation, I want that to change into a negative 4x. So I'm going to multiply by negative 4, and I'll distribute that to all of the parts. So I can write that down here, negative 4x. Negative 4 times a negative 2y is going to be positive 8y. And negative 4 times 20 is going to be negative 80. X's go away. 15y equals negative 75. So that's kind of big there, I know. But when we divide, we know they're different signs, so we'll get a negative. And that should be negative 5. To find the x, I would use the top equation. Again, no coefficient in front of the x. So I have x plus a negative 2 times negative 5 equals 20. Negative 2 times negative 5 is positive 10. So x is going to be 10. So my ordered pair is going to be 10 and negative 5. Last one. There's no getting around it this time. I'm going to have to multiply both equations by something. And I do like that either with the x's or with the y's, I already have one positive, one negative in each of them. If I look at the x's, a lot of people would say, oh, we have to go all the way up to 24, but that's not really true. I could make the negative 4 and the positive 6, I could make both into 12s, a negative 12 and a positive 12. The y's I can make into 15s. And you know what? I'm going to try to keep this as small as I can. So I'm going to work on my x's. I'm going to get this top x right here. I want that to be a negative 12x. It's already negative, so I'm going to keep it negative and I'm going to multiply by 3. For my second equation, I want this to be positive 12x. So I'm going to multiply by 2. So we do have to multiply both equations with all of this distribution. So first equation is going to be a negative 12x plus 9y equals negative 12. Second equation, 12x, that's what we wanted, minus 10y, or plus a negative 10y, equals 4. X's are gone. 9y, negative 10y, that's a negative 1y. Negative 12 plus 4 is a negative 8. And then we'll divide. So y is 8. Now that I know that, I need to find the x. And again, it really, truly does not matter which equation you use. I'm going to use this one. So I'll have 6x minus 5 times 8 equals 2. When I add the 40 to get rid of it, I get that 6x equals 42. And x will be equal to 7. So my ordered pair here is going to be 7, 8. By now, we've been working with elimination for quite a while. I'm hoping that you're feeling pretty comfortable with this. The worksheet today is 7-4 for your practice problems. The answer key is in Schoology, and when you're done, there's a formative in Schoology. Let me know if you need any help.